Hey, good morning. Welcome to First Step Science. We are going to take a look at water today. And I have my great big globe here. And I like this one because it just reminds me of how Earth would look from space. And so when you look at Earth from space, you can see evidence of water. Take a look at that. Do you know what those are? The evidence that Earth has water? Aha! It's clouds. We are the water planet. So not only does Earth have oceans, liquid oceans, but it has condensation in the clouds, and that's water in the gas form. And then also, even though it's a ball with a sticker on it, you can take a look, and the polar regions of our Earth has water in the solid form. Check that out. Oh, yeah, that's the North Pole. But anyway, the polar caps, ice, gas, and liquid. So we are the water planet, and we're just blessed with water, and that makes all life on Earth. So it's kind of fun to notice things about water and do some science with water so we know what water is all about, because it's really important to our whole Earth. So here we go. One of the things we're going to do today is all about surface tension and water molecules. Now, what does that mean? We're going to do a couple of experiments where we can kind of explain that water likes to hang on to itself. So if you're a water molecule, you're looking to bond, or you're attracted by other water molecules, and you hang on to each other. And so when you pour water in a dish or a glass, they hang on to each other, especially on the surface too. So let's take a look at my camera and let's do an experiment all about surface tension. So I have a penny in the middle here, and I have an eyedropper. This is what you're going to need to do this experiment. And I have a little cup of water. And what we're going to do is try to see how many drops of water we can fit onto the head of a penny, because those water molecules are hanging on to each other and they're not going to let go. And even though the penny is a flat surface, it's got a little ridge on it, how many drops of water can we put on the head of a penny to show us surface tension and how water molecules hang on to each other? So I'm dipping my pipette into the water, and I'm going to do it drop by drop on my penny head to see how many. So if you count with me, we can go 1, 2, 3, 4, 5, 6, 7, 8, and it's still there. Can you see the bead of water still there on the penny? Did I get to 8? Here's 9, 10, 11, 12, 13, 14, 15, and still hanging on to the penny. 16, 17, oops, didn't spill over yet. 18, 19, 20, oh, it's still going. 21, 22, 23, 24, 25, 26, 27, oh, 27, did you see it spill over? Wow, that's a lot. So you can do this experiment over and over again to challenge yourself to see how much that you can put on the head of a penny. Just drop by drop, slowly put some on, and you can see how the water likes to hang on. Water molecules like to hang on to each other. I didn't count this time, I'm just dropping it. But it seems like a whole lot of water on one little penny. You can do it with other coins too. You can do a quarter or a nickel or a dime. Whoops, and there we go. Surface tension. And so that's our first experiment with surface tension. Our second one is with a dish, like a pie pan, a little soap, and some pepper. And So we're going to pour a big bunch of water into the pie pan. And this time we're going to see if we can break up the force of surface tension. So I'm pouring a bunch of water into my pie pan. There we go. Can you see that? Yeah, you can see that. Anyway, so I'm going to put some pepper floating on the top of my dish of water. Now you don't have to have a pie pan. You could have a plate or a saucer. And so I'm going to sprinkle my pepper, oops, there we go, onto the surface of the water. There, can you see it? I'm going to put a whole bunch on there. So what we're going to attempt to do right now is see if we can break up the surface tension of the water. Water has lots of qualities. Surface tension is one of them. There, can you see all the pepper? So what will break up that surface tension? What will bust up the attraction of the water molecules to each other? Well, what I've got here in my little cup is a little bit of soap, and I've got another pipette, and I'm going to put a little bit of soap into my pipette, and I'm going to put one drop right in the middle of my pepper plate. Let's see, if we break up the surface tension, something strange is going to happen to the pepper. What do you think will happen? Let's see, here we go. Drop of soap. Whoa! Soap. The soap broke the surface tension, and the pepper went all the way over to the side, and it only took one tiny drop. So you can try that yourself too. And so now you can see that some of the surface tension is broken a little bit, and some of the pepper has fallen to the bottom. Can you see those specks? Yeah. And then the rest is still floating, but it spread it all up. That experiment is called scaring pepper. The pepper got scared all the way to the side. But no, it was really the force of the soap molecules. All right, so there is my scaring pepper surface tension experiment. And so, yeah, water has lots of properties. That one was a liquid, and of course, water hangs on to each other. So now we're going to do an experiment with a solid, which is ice. Oops, I got the wrong thing, but that's all right. Okay, here we go. We're going to move the other experiment over here. So I have some ice, and I have a plate, and I have a piece of string, and I have some salt. So this challenge or this experiment is to see if we can pick up an ice cube with a piece of string. Okay, can you see my ice cube here? And there's my string, and I'm trying to get my ice cube to stick to that string so I can lift that ice cube right off my plate. But I can't do it until I melt and freeze that solid ice. So if I put a little bit of salt onto the ice, it's gonna melt the ice a little bit, but maybe freeze it back together. That's why they use salt on the road to melt the ice in the wintertime. But then if the temperature is cold enough, it freezes back together. So let's see if I can put this string onto the ice cube and see if it will freeze back together. Right now, it doesn't look like it's working, but I've done it before. So I'm going to add a little more salt. Come on. And that's actually, I'm going to do some just regular table salt. Whole bunch. A little finer grain. Let's see if it's working. Is the ice melting? The ice is definitely melting with salt. But my string is not getting stuck down in there. Oh. Some of the experiments and the challenges that I do here, sometimes it takes a little while for them to work. Let's see. Oh, it's not sticking. Maybe my string is too thick. What do you think? Well, I definitely have been melting a little groove in my ice. So we know, even if I don't end up being able to pick up this ice cube with my piece of string, maybe a little bit later, we'll set this one aside. At least we know that salt definitely melts ice. Salt water doesn't freeze as fast as water without salt too. So there we go. Well, we're going to come back to that one. Maybe it takes a little while for that ice to get melted by the salt. So there's water in its solid form, which is ice. Now, what about ice, or what about water in its gas or condensation form? There's water in our air around us. And as it rises to different elevations in our atmosphere, like you saw our Earth ball, it condenses and becomes clouds. But I have a little cup here that I put some ice in. Can you see it? There's some ice in there. And it makes the sides of the glass really, really, really cold. So we're capturing the moisture or the gas, the water vapor in the air on the edge of the glass. And so when I turn it this way and I rub my finger down it, you can feel the condensation. You can feel it on your hand. Now this was a dry glass when I started. I put the ice in it. I didn't spill it. And now the moisture or water vapor in the air is condensing on the side of the glass. And you can feel it and you can see it. There we go. So solid, liquid, and gas for our water. Okay. So water has other properties. It can absorb things. And so we're going to do a little bit of an absorption experiment. Now, if you saw the list of supplies together ahead of time, one of the things that we said was a muffin tin. And then you can decide what you want to put into your muffin pan to see if it absorbs water or not. Now, what does absorb mean? It means it kind of sucks it up. And that's a very important property of water. So what I'm going to do is I dropped my little pipette on the floor here. I'm going to grab it. And let's see if some of these things that I put in the muffin tin will absorb water. So here's my water. And I'm going to use a little pipette like this. We're going to drop things into the muffin tin, substance by substance, to see if water will be absorbed. So the first one I want to try, and this is an easy one. This is a little piece of sponge that I put in the muffin tin, and I'm going to drop some water on that sponge, and let's see. Do you think the sponge absorbs water? Ooh, it's getting bigger. Did you see that? Yeah, it did. So you can do your own little experiment by, oh, and look at that. I can squeeze the water right out of it, and then I can absorb it again. Look at that. Oh, pretty cool. So how about a button? Do you think water will run off or get sucked up by the button? Let's do a little bit here. I think if you made a prediction, my prediction was that button is not going to suck up or absorb any water. Nope. Nope. So let's try a piece of cotton. This one right here is a piece of cotton. So I'm dropping some water onto my piece of cotton. Wow. There we go. Oh, yeah. Check that out. There's a lot of water that got absorbed by the cotton. And then I can suck it back up again. Whoa. So let's see. Oh, here's a leaf. Let's see what happens if I put some water on a leaf, a little piece of a leaf. It just rolls right off. And you've probably seen that out in nature. There's a little waxy substance on a lot of leaves, and a lot of times the water just beads up and rolls right off. So leaves aren't very absorbent. How about a rock? Absorb or roll off. Oop. Oh my goodness. That's kind of interesting. Look at the surface of that rock. It was white before, and now I think it must have absorbed just a little bit just on the surface, but of course it's not like a sponge. It absorbed a little tiny bit. And of course, here's our penny. We did a penny before. And if I squirted slower, I could do the surface tension experiment, but I didn't. But no, the penny's not going to absorb any water. How about a cap of a pop bottle? No. Those are very, very slippery kind of surfaces, very hard surfaces. Oh, here's some construction paper. Let's try this. What's happening? Oh, a little. Oh, yeah, it's absorbing. Paper is absorbing the water. Let's see. Okay. A little bit. It's getting soggy. How about some popcorn? So you can do this experiment at home with a lot of different substances. I just had some popcorn left over from my snack last night and decided to see if it absorbed water. Yeah, it does. It's getting soggy, but it's not going to be crispy popcorn anymore, but it is absorbing the water. How about aluminum foil? Nope. It's running right off. And a piece of glass. Nope. It's running right off the glass. Oh, and I have one left. A piece of fabric. Shall we try with that? Well, it seems to be rolling off a little bit, but not entirely. Oh, and now it's absorbing it. Wow. Okay, so that's kind of fun to do. So you can make your own predictions and see what water does to things. Water does a lot of things like absorbing and running off and mixing in with things. Oh, you could even do sand. You could do sand or mud or grass. So use your imagination and see what you can come up with from around your house and try that at home. Okay, so I got my eye on this string thing again, and I'm not sure it's happening yet. Nope, not yet. I think maybe my string is too thick. We'll see. Anyway, so now I'm going to change my camera, and we're going to do a couple of things back behind me with mixing water in its liquid form to see what it does. There we go. See my tray? So I'm going to bring that a little bit forward so you can see what I'm doing. So water has the ability to, as you can see, either absorb and mix with things. So we're going to see what makes a good solution. So I'm going to try some salt. And we're going to make a solution by taking some jars that I have here and see if we can make salt disappear into the water. There's salt molecules and water molecules, and they sort of dance around each other. There's a little bit of salt, and we're going to stir it. We need a spoon for this one. And we're going to stir it and see if you can make the grains of salt disappear into the water. Yeah. Okay. Stir it enough. There we go. I don't see any grains of salt. So I'm going to do that again with my next jar so you can see it up close a little better. Because I'm not sure you can see. There's water. And here's some salt. And you can see the salt grains floating down into the water. And when you look into your jar, you can see the salt grains on the bottom just laying there. And so let's see if we kind of make those molecules dance around each other, move faster. Are we able to those salt grains and salt make a mixture or a solution in my jar and make all of those molecules disappear? Did I do it yet? I'm looking down at the bottom and I see a few salt grains still. There we go. So what else might, the water has molecules that attract other things. So there's a lot of things that you could put in here that would just completely disappear into a solution. Other things won't. Some of the things might be repelled by the water molecules. And that's what we're going to try next in my last jar. I've just got some water in here, and we're going to try to mix water and oil together. Have you ever heard the expression, water and oil don't mix? And why is that? We're going to show it here up close. And so I'm going to put some food coloring into my water so you'll be able to see the water is going to change color a little bit here. And I'm going to stir that up so you can see where the water is. Now I've got purple water in my jar because water and food coloring definitely do mix. But then I'm going to see what happens when I put in some cooking oil. What will happen? Do you think the cooking oil will mix in with the molecules of the water? Let's find out. Whoa, I'm pouring a bunch of cooking oil in there. I'm not so sure you can see it from this distance, so I'm going to hold it up to the screen and put some in there. I'm going to have to get some cooking oil at the store. Okay, let's see what it looks like up close. Wow, can you see the cooking oil kind of sitting on the top? Yeah, that's pretty cool. So it looks to me like the water molecules and the oil molecules are not mixing in with each other. In other words, instead of the oil molecules attracting to the water molecules, they're repelling each other. Let's see. I stirred it a little bit and they're coming all the way to the top. All right, now let's get a little bit more active here. I have a jar lid and I'm going to put that on top and see how the water is making that oil float to the top. I put on the jar lid nice and tight. I'm going to shake it. That should definitely, if it was going to make a mixture or a solution, shaking it like this would definitely work, don't you think? But let's see what happens to the oil. Slowly but surely, it's starting to come to the top. Now it did for a little bit, but I'm looking at it and you can see slowly. I've also mixed a little bit of air into this situation, but you can see how the oil is definitely floating to the top. Water is a little denser than oil, so it's making a little heavier. So it's making the oil float to the top. They're not mixing in with each other. It's kind of like a little dance. Water molecules are dancing with each other. And the oil molecules are so big and so fat, they're just separating themselves out. There we go. So you can try that experiment at home too and see what you come up with. All right, so I'm going to take this tray away, and for our last thing to do, we are going to make a water scope. Now scientists use a lot of different tools And have you ever noticed that you really can't see very well underwater? Like if you went swimming and you dove into the lake or the river or the pool and you opened your eyes, you can't really see. You can't really see under the water. So what we're going to do is make a water scope out of a plastic glass, but you can also make it out of a couple of different things. So I'm going to show you the materials that I'm using. You could make a water scope out of something simple like a Coke bottle or a peanut butter jar or a small plastic cup. Then I have a large plastic cup today, so that's what we're going to use. We're also going to use a couple of rubber bands. And you can either use something like a Ziploc bag or some clear plastic wrap. I've got Glad wrap here, saran wrap too, but that's what we're going to use to make a water scope so we can see underwater. Now, when we take and try to see underwater, why can't we see? What's going on with that? It's because light is bent by what it's passing through. So when light passes through the air, it's bent a little bit, but our eyes inside there focus it on the back of our eye, and we can see images that are focused. But when light passes through water, it's almost the same as, there's a lot of liquid in your body and a lot of liquid in your eyeball. And so when light passes through water, it's the same as passing through the liquid in your eye. And the eye just can't have enough space in there to focus it. So it's a fuzzy image, and that's why we can't see underwater. But if we use something that adds air in between our eye and the water, then we can see again. That's why goggles work. That's why face masks for scuba divers work. And that's why a lot of animals have a second eyelid that helps them see underwater, like beaver. Anyway, so here is what we're going to build our water scope out of. So you could see underneath the water in your bathtub and look at your toes or something. Or you could see, if you had a pond nearby, you could use this to look in and see what's underneath the water, because the light will focus on your eye. It's a tool. So it's actually a scientific tool. So there's a simple one. So to do this, you can use anything that you have, but you have to be able to cut it apart, and that might take an adult because it's a little pokey with scissors. So what I'm going to do is I'm going to cut the bottom off I poked my scissors right in there, and I'm cutting the bottom off my plastic cup. That's the hard part, the only hard part. Okay, or if I was using a pop bottle, I would cut the bottom off, then I'd be able to look in it. I'll show you how to do that. So now we have, it's kind of like a tube, an open end. So how are we gonna make it? If I stuck it into the water would just come up the sides and I couldn't see anything. So we're gonna close off the end of the tube. And to do that, I'm gonna use my plastic wrap here like this. Pull a good amount out, rip it off, and stick it over the end of my plastic cup that I made here. See that? Oops, just dropped my pop bottle. And then I'm gonna hold it down with a rubber band. And then I'm gonna pull it tight. So it's like a little lens right there. Okay, so it's my water scoop. So I did it with the small end because once you cut plastic, sometimes it's a little sharp, and I want to put this part that's not sharp on my eyes and my face. Okay, so there it is. That's as easy. You can decorate the sides if you want, but it might be a little distracting if you're trying to look at something underwater. And you can also trim the plastic wrap off with your scissors. so it's not flopping around as much. But you don't have to, because you do want some just sticking out so that you can keep pulling it nice and tight. Okay, so there you have it. You can take and look inside, and you can look underwater. So if you have a stream that you want to check out, or a pond, or your bathtub, hold it up to your eyes and stick it in, and you can see underwater. So if you put just something like a penny, I just put a penny in the bottom of my cup. I can take my water scope, hold it in, hold it down, and look. And I can see if it's heads or tails. It's that good. All right, so that's our project for today. Hope you had a good time. Hope you try some things at home. And join us again next time for First Step Science. I saw something I had never, ever seen before. And here's where you get to make a choice. Was it a giant Tyrannosaurus Rex? Okay, so now how are we going to paint the pine cones? Maybe 3 pine cones. What do you think? Yeah, 3 pine cones. And then the fun starts. What's happening here? Well, when we pull back on our little shooter here, that creates potential energy, and then when I let it fly, it turns that potential energy into kinetic energy. Kinetic energy is the energy of motion, and boom!